Hi, scholars. Happy Monday. Today is Monday, May 11th. We are down to 2 weeks left of school before you guys graduate from fifth grade and head on to middle school. Very exciting. We will have an end of the year math assessment covering everything you have learned this year in fifth grade math next week on Wednesday. So that's Wednesday, May 20th. And then we'll do something really fun Thursday, Friday, and then you will be done. So I'll be telling you more about that, but just wanted to give you a heads up. You will have an end of the year math assessment with everything we've learned so far this year in fifth grade math, just to make sure you are very prepared for sixth grade next year. Very exciting. All right, I want to dive right into our math, starting with some shout outs for 100% scholars from Friday's assignment. This was a tricky one. We had lots of scholars showing up to office hours on Friday. I know a few of you missed the early time of office hours and reached out saying you wanted some more help. So please come to today's office hours at their usual time, 3:15, for continued practice multiplying fractions. But huge shout out to Emmanuel, Tenbeat, and Naira, Abimael, Philip, Michelle, Edwin, and Madeline. This was tricky. A lot of us made some kind of careless mistakes as we were multiplying fractions, so excited to have some time to practice a little bit more today. Today, we are going to be reviewing our steps for multiplying fractions, and we're moving on to dividing fractions as well. We're going to be looking at a lot of different word problems to make sure we understand when am I multiplying, when am I dividing, and how can I draw it out, draw a model if I'm ever stuck to make sure I really understand what the problem is asking. All right, so let's take a look at our first problem. This is one that you had on Friday, but only 17 out of 60 of us actually got this correct. So let's first read and see what it is asking us. On Sunday, Miguel ran 4 3/4 miles. On Monday, he ran 1/3 of the distance he ran on Sunday. How far did Miguel run on Monday? All right, the most common mistake that I saw was actually scholars who added these two amounts together. They added how much he ran on Sunday with how much he ran on Monday. But as I reread this problem, it's not saying on Sunday Miguel ran 4 3/4 miles, on Monday he ran 1/3 mile. How far did he run altogether? So I'm not adding these. In fact, the question is asking me, how far did Miguel run on Monday? So my job is to figure out how far did he go? And I don't actually know how far he went on Monday. I know how far he went on Sunday, and I know on Monday he ran 1/3. I know he ran 1/3 of the distance he ran on Sunday. And so I've got to go back to those clue words when I hear that he ran a fraction of another fraction. That's a really good clue that it's multiplication. But let's draw it out and see if we can figure out how far he actually ran on Monday. You have your scrap paper ready, you have your pencil ready to go, you're solving this along with me. So even before I worry about the number sentence to match this story, I'm just going to start by drawing a model of what I know. Well, on Sunday, he ran 4 3/4 miles. So I'm just going to draw one box to represent every mile that Miguel ran. He ran 4 whole miles, and then he ran 3/4 of a mile. Which I'm just going to show by lightly shading in these 3/4. So this is the amount that Miguel ran. This is representing my 4 3/4 miles. That's how far that he ran on Sunday. Now on Monday, did he run further or did he run more or less? Did he go further or shorter than he ran on Sunday? Go ahead and show me with your hands. On Monday, did he run more or did he run less than he ran on Sunday? That's exactly right. He ran less on Monday. He only ran a third of the distance. He only ran a fraction of the distance that he ran on Sunday. I'm guessing that Miguel ran so far and maybe so fast on Sunday that by Monday he was a little bit tired, so he did not run as far. He only ran a third of the distance. So some of us hear that clue word, he ran 1/3 of the distance. We know we are multiplying, but let's make sure we can prove it with this model. So if this is the amount he ran on Sunday, I want to show how far he ran on Monday by showing 1/3 of this. So I'm going to take every whole mile he ran, and I'm going to cut my whole miles into thirds and just shade in the amount that he ran. So it's like if every whole mile he ran on Sunday, on Monday he only went a third of that mile. All right, I'm pretty good at that when it comes to our whole miles. So I can see where we have 1/3, 2/3, 3/3, 4/3. But I need to make sure I'm also taking 1/3 of this 3/4. Again, when we hear something like 1/3 of 3/4, we know that's multiplication, but let's show it by actually splitting these 3/4 into thirds. And I'm just going to shade in 1/3, just like I did for the whole miles. And now let's figure out how far he actually went on Monday. So he went 1/3 of this mile, 1/3 of this mile, 1/3 of this mile, 1/3 of this mile. And then here we have 3. You can see my 3 pieces right here, but it's not 3 out of 9 because I have to count how many pieces in the whole mile, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3/12. So this is how far he ran on Monday. So now I just need to add it all up. 1/3 plus 1/3 plus 1/3 plus 1/3. That's going to be 4/3, which we know is the same as 1 1/3. And then I just need to add my 3/12. So 1 1/3 plus 3/12. Before I can add this, now I need to find a common denominator. I can't add thirds and 12ths without my common denominator. So I would turn this into 1, and let's see, multiply 3 times 4. So 1 times 4, this would be 1 4/12 plus 3/12. Luckily, we are experts at adding fractions. I know 1 4/12 plus 3/12 is 1 7/12. So on Monday, he only ran 1 7/12 miles. That makes sense because I know he ran less on Monday than he did on Sunday. In fact, 1/3 of the distance. So on Sunday, he did this long run, 4 3/4 miles. And then on Monday, he only did a third of that. So he just did a piece of that run. It's got to be a shorter run. And when I figured out exactly how long it was, by taking 1/3 of each whole mile and 1/3 of his 3/4, we figured out that he went 1 7/12 miles on Monday. So I could solve it by drawing out a diagram. I could also solve it by using one of the 2 strategies we practiced last week. I understand now that this is multiplication, so I could set up my problem as 4 3/4 times 1/3. One thing I could do is use partial products. So I could draw my array to make sure I'm getting all of my numbers In there, I'm going to split up 4 3/4 into 4 3/4. And then I just have 1/3. Now I can multiply. 4 times 1/3 is 4/3, which we know is equal to 1 1/3. 1/3 times 3/4, I multiply my numerators and I multiply my denominators to get to 3/12. So we are once again, we have 1 1/3 plus 3/12. This matches exactly what we got when we drew a model. 1 1/3 plus 3/12. We've already found a common denominator, and we know that when we turn them both into 12s, this is going to equal 1 7/12. I can see how here, when I did 1/3 times 4, that was like in my model when I took 1/3 of 4 and got 4/3 or 1 1/3. And then when I did 1/3 times 3/4, it's just what I'm showing in the model right here. So as long as we understand how to use partial products, this can be a little bit faster. If we're stuck though and we don't understand if we're multiplying, drawing it out is a great strategy. Let's take a look at just one more strategy that some of us like to use, where we actually turn our mixed numbers into improper fractions. So here I'm going to turn 4 3/4 into an improper fraction by doing 4 times 4 is 16. Plus 3 more, 16, 17, 18, 19. So this is 19/4 times 1/3. Now I can just multiply using my regular standard algorithm for multiplication of fractions. 19 times 1 is 19, and 4 times 3 is 12. I don't just want to leave it as 19/12. That's harder for me to really picture how far is Miguel really running. So instead, I want to take out 12/12, which would give me 1 whole, and I'm left with 7/12. One problem, 3 ways. Totally up to you how you want to solve it. We need to understand that this is asking us to multiply. I should not see scholars adding problems like this because it's not asking me how far he ran altogether. It's not telling me a distance for Sunday and a distance for Monday and asking us to join them together. We need to read the questions carefully so we can really understand what they're asking. All right, so this was one example where we needed to multiply our fractions. If we didn't realize that right away, we could have drawn out our 4 3/4 miles, and then found 1/3 of each of those miles. Let's take a look at another type of problem. All right, follow along as I read, and then we'll see about how we can set it up. Dr. Zamora bought 8 cakes to send to some teachers. If a serving of cake equals 1/4 of a cake, how many servings of cake does Dr. Zamora have? So as you know, last week was Teacher Appreciation Week. So Dr. Zamora was sending teachers all kinds of things. We got so many fun things in the mail. I'm just showing her appreciation. So in this story, Dr. Zamora has 8 cakes. So I'm picturing the 8 cakes that she has. Now, a teacher does not need to eat an entire cake by themselves. That would be a lot of cake. So if she has 8 cakes, it says that 1 serving is just 1/4 of a cake. That makes sense. That seems like a really appropriate amount of cake to eat, 1/4 of a cake. And I want to know, how many servings of cake does she have? Or another way of thinking of it is, how many teachers can she feed with these 8 cakes? I know she can feed more than 8 teachers because she has 8 cakes and she's cutting each of her cakes, and that has got to give her more pieces. She's not giving each teacher a whole cake. So even before I start thinking about a number sentence that matches this story, let's just draw out and make a model what we know, just like we did with Miguel's run. So let's start in the beginning. Dr. Zamora has 8 cakes. I'm going to draw square cakes because they're just easier for me to cut into nice even fractions. So I'm going to draw out the 8 cakes that Dr. Zamora bought. Now, this is what she bought, but she's not sending every teacher a whole cake. She's not saying, well, Miss Alperin, you can eat this whole cake, and Miss Cuppernell, you can eat this whole cake, and Miss Trotter, you can eat this whole cake. We're not each getting a whole cake. Instead, she's saying, well, you really only need to eat a fourth of a cake. That seems very reasonable. So before Dr. Zamora can even put these cakes in the mail and send them, she needs to cut them into fourths. So let's go ahead and cut our cakes into fourths. You're doing this on your paper along with me. We're drawing this model to really visualize what's going on in this story. So now as I look at this, I'm thinking, well, every teacher is getting 1/4 of a cake. So like when I go and check my mail and I have my piece of cake, this would be my piece of cake right here. I could eat this piece right here. I'm just gonna label that one as Miss A, so Miss Alperin gets that cake. And then Mrs. Dunn could get this piece of cake. And Miss Trotter could get this piece of cake. And Miss Richardson could get this piece of cake. And you start to get to the idea. Don't worry, I'm not going to pass out all the pieces of cake. But my question is, how many servings of cake does Dr. Zamora have? Well, with this cake, I can see she already served 1, 2, 3, 4 people. So let's go ahead and count up how many servings of cake she has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So she has 32 servings of cake. Now, if I want to write a number sentence that matches this, am I multiplying fractions? I'm not. I'm not doing 8 cakes times 1/4. Instead, she's taking her 8 cakes and we're actually dividing them into pieces that are each 1/4. And when we did 8 divided by 1/4, remember that each piece is 1/4 of a cake. And we counted up all of the pieces of cake, we got 32. So 8 divided by 1/4 is 32. Tomorrow, we're going to talk a little bit more about some standard algorithm ways of solving these, but today we're just going to draw a model to make sure we really understand what we're doing. So when I took my 8 cakes and gave everybody a piece that was 1/4, we could actually feed 32 people. Now, you don't have to count by ones. I know a lot of you are thinking, we're almost 6th graders, let's make this a little bit more efficient. We could have counted our pieces by 4s. So we could have counted by 4s 8 times to get us to 32. There's something to think about as we start to think more tomorrow about a standard algorithm way of solving 8 divided by 1/4. All right, let's take a look at another question. All right, this is a story about Corday. So as you know, Corday won the pizza a couple weeks ago. Excited to see who wins the next pizza. I'll be announced today. Make sure you are at virtual social lunch. And so Corday had 1/4 of his pizza left over. And he decided that he wanted to eat an equal amount of the leftover pizza for lunch for the next 2 days. And he needs to figure out, well, how much pizza can he eat each day? So first, I'm just visualizing what's happened in this story. I'm picturing Corday, when he first got it, he had a whole pizza. But he doesn't have a whole pizza anymore. He only has 1/4 of his pizza left over. So he has this much smaller piece, a fourth of his pizza. Now, the only pizza he has left is this 1/4 of the pizza. And he wants to eat that 1/4 of the pizza over 2 days. And he needs to figure out, well, how much can he eat if he wants to split his 1/4 of a pizza over 2 days? So I know that Corday has to eat less than 1/4 of a pizza each day because he only has 1/4 of a pizza. So he can't eat more than 1/4 of a pizza. In fact, if he ate 1/4 of his pizza on Monday, he would have no pizza left to eat on Tuesday. So he's got to eat less than that fourth today, so he has some that he can eat tomorrow. Before we even start thinking about whether this is multiplying fractions, whether it's dividing fractions, let's just draw a model of what we know. So I'm going to draw Corday's pizza. I'm going to draw it as a square just because for me it's easier to split squares into even fractions. So this was Corday's pizza when he first got it from Domino's. But he doesn't have the whole thing left. Corday only has 1/4 of his pizza left. So I just want to show the amount of pizza that he has left. I'm going to cross these out because he already ate these pieces. This is the 1/4 that he has left over. So the only pizza that we can even think about is just this piece right here. He's already eaten the rest of the pizza. Now, here's his 1/4 of the pizza that's left over, but he doesn't want to eat it all in one day. He wants to make this pizza last, so he wants to eat this over 2 days. And he wants to have an equal amount each day. So I just want to split this into 2. So he could eat this piece on Monday and this piece on Tuesday. Now remember that our question is asking, how much pizza should he eat? What fraction of the whole pizza? So I need to figure out what fraction of the whole pizza is this amount that he's going to eat Monday. And I know it's the same amount that he's going to eat Tuesday. Now, and I can't just say this is 1/2 because this is not 1/2 of the whole pizza. I've got to consider the whole pizza. So this is where I like to draw my little dotted lines to show how the pizza would be split up. And I want to see how many pieces there would be in the entire pizza. Well, there would be 1, 2, 3, 4, 5, 6, 7, 8. So Corday is going to eat 1. Here's the 1 piece he's going to eat out of 8, or 1/8 of the pizza each day. If he eats 1/8 today and then 1/8 tomorrow, 1/8 plus 1/8 would be 2/8, which is the same as 1/4. So that equals the 1/4 he has left over. Let's think about a number sentence that matches what's going on. Corday is starting with 1/4 of a pizza. I know in our last story, Dr. Zamora was starting with 8 cakes. So my 8 came first. Here, Corday is starting with 1/4 of a pizza. And then he's dividing that 1/4 of a pizza into 2 days. And when he divides his 1/4 of a pizza into 2 days, he was able to eat 1/8 of his pizza on each day. Again, tomorrow we're going to talk more about some standard algorithms we can use for dividing fractions. Today we're really visualizing what the story is asking. All right. We're going to do some practice. We are going to be drawing some models to show both multiplication and division of fractions so that we really understand what we need to do to solve and why. So let's start with our very first problem right here. We have 3/4 times, we have 3 4/5 times 1/6. Let's go ahead and copy the problem down. Now, if I were going to draw this out, I would draw my 3 holes and then 4/5. I'm just going to shade them in lightly. So this represents my 3 4/5. And then we're multiplying by 1/6, so we're taking 1/6 of the entire thing, and I can solve that by taking 1/6 of each piece. So I can split this piece into sixths and shade in one of them. I can split this piece into sixths. You have this on your paper. You are practicing drawing this model. And I can split this piece into sixths. So I've shown 1/6 of my 3 holes. And now I need to take 1/6 of my 4/5. So I need to split this 4/5 into sixths. And I'm just going to dark shade in 1/6 of it. And now I should need to figure out how much is shaded in all together. So I have 1/6, 2/6, 3/6. So I have 3/6. That was when we took 1/6 of the 3 holes. And now I need to find how much was 1/6 of 4/6. Well, it looks like I have 1, 2, 3, 4 pieces shaded in out of what would have been 30 pieces altogether. I know I need to find a common denominator, so I'm going to turn my 3/6 into 30ths. To do that, I'm going to think 6 times 5 is 30, 3 times 5 is 15. And I'm going to get to a total product of 19/30ths. This is when I drew a model. I want to make sure we know how to draw a model. So if we're ever stuck, whether it's a number sentence like this, or it's a word problem and we're not quite sure, do I multiply, do I divide? We have a strategy for drawing a model. But now let's practice a slightly more efficient way of doing it. I want you to pick your favorite way. Either solve it using partial products with an array or solve it by converting your mixed numbers into improper fractions and solve. Go ahead and take 2 minutes. If you solve it one way and you have some time, go ahead and solve it in another way. This is problem number 1, 3 4/5 times 1/6. Take 20 more seconds to finish up. Remember, this is what we got when we used a model. All right, let's check in on the strategy that you used. So whether I used partial products or converting my mixed number into an improper fraction, I still got to the same answer of 19/30ths. We did either 1/6 times 3, which is 3/6. We saw that already in the model. And then 1/6 times 4/5, which is 4/30. We saw that in the model as well. And we added those together. We'd already found our common denominator, and we knew that was 19/30. If you solved it using an improper fraction, check your work right there. We know how to solve multiplication of fractions with a standard algorithm, so I do urge you to use that, but always go back to your model if you're not exactly sure what the problem is asking or you're stuck on your partial products. All right, let's move on to question number 2. Today, we're going to be just drawing models to show how this fraction division would work. So we don't have a story problem, but we can still draw out exactly what's happening. 4 divided by 1/3. If it helps you to think of it in terms of something you can divide, I love to think about pans of brownies because I love brownies. So I can think of this as 4 pans of brownies, and each pan of brownies is being divided into thirds. And then I want to know, well, how many pieces am I going to have? How many pieces of brownie once I cut them into thirds? Go ahead and draw this one out. I'll be doing it up here. I want you to try it on your paper so you're prepared when you're doing this completely on your own, and you're prepared when you are doing this on your test next Wednesday, so we know you are ready for 6th grade. Go ahead and try drawing this out on your own, thinking about what we're starting with. Check to see if yours matches mine. And then I'm thinking about, okay, if these are my pans of brownies and I cut them into pieces that are thirds, how many pieces of brownies do I have now? Well, I'm just going to count them. If you want to count by something faster than ones, that is great. I probably should not be counting by ones because I can count by something much faster. I now have 12 pieces of brownie. We're noticing that our quotient here got bigger. That makes sense because I had 4 pans of brownies, but then I cut each one into smaller pieces so I can feed more people. I can now give 12 people a piece of brownie, which makes sense because nobody needs to eat a whole pan of brownies all by themselves. All right, let's try number 3. Again, there's no story, but I can still think of this as brownies again if I want. Now I'm starting with just 1/5 of a pan of brownies, but I have to divide that 1/5 of a pan with 4 people. And so here I'm expecting an answer that's going to be smaller because I'm smaller than 4 because I'm only starting with 1/5. And I'm cutting it into even smaller pieces, so my quotient will get actually smaller. So before we even write down our number sentence, let's just draw out what we know. In problem 2, I had 4 to start with, so I drew out my 4 wholes. Now I only have 1/5, so let's draw out our 1/5. I'm just going to lightly shade in the 1/5 that we have. If it helps me, I can cross this out. It's like I don't even have it. It's like the pizza that Corday had already eaten. This would be like maybe if I made a batch of brownies and was really hungry and I'd eaten 4/5 of them and I only have this 1/5 left, and now I want to split this 1/5 into 4 pieces. So let's split our 1/5 into 4 pieces. And then your job is to figure out what is the size of each one of those pieces. Don't tell me it's 1/4. This is not 1/4 of the whole pan of brownies. If you need to draw your dotted lines in there, go ahead and do that. And then go ahead and let me know how big each of those pieces is. All right. And each piece is 1/20th. So 1/5 divided by 4 is 1/20th. You may be starting to see some patterns with these numbers. You may be starting to remember a little bit of, oh yeah, actually I remember the standard algorithm for dividing fractions. That's so great. We're gonna talk more about that tomorrow. Today we're really making sure we can draw out the model to understand what we are doing. All right, and number 4, we have another multiplication practice. If you need to draw a model, go ahead and draw a model. If you feel comfortable using the standard algorithm, either through partial products or by turning your mixed number into an improper fraction, go ahead and do that as well. Go ahead and solve number 4. I'm gonna solve it too, and then we'll check in with your answer. All right, let's check in and see what you got. If you used partial products, you were doing 2/7 times 1 and 2/7 times 1/3. When you then found your common denominator and added, you should have gotten 6/21 plus 2/21, which gives you a total of 8/21, or 8/21. If you converted to an improper fraction, 2/7 would have stayed the same. You could have turned 1 1/3 into 4/3. Boom, multiply straight across using that standard algorithm for multiplication and got an answer of 8/21, or 8/21. If you wanted to draw it out with a model, you could draw your 1 1/3. I shaded in like lightly my third right here, and I just took 2/7 of each of those pieces. Still got to an answer of 8/21. All right, a couple more to practice, and then you have some to try on your own. These problems take up a lot of space. I use up a lot of paper when I'm doing mine, so I want to make sure I have plenty of space. Make sure you have enough paper. We got a couple more. Now we're going to get into some word problems. All right, sometimes this is the trickiest part, is figuring out what is this question asking me to do. Do I need to be multiplying? Am I adding? Am I dividing? Am I subtracting? When you're stuck, draw out what's happening. Then even if you're not exactly sure, if you multiplied or if you divided, you can still get to the right answer and then start to figure out, okay, was this a multiplication problem or a division problem or an addition problem? Let's take a look at problem 1. Ashley cut 3/7 of her red rope. She used 5/7 of the cut piece of rope to make a necklace. What fraction of her rope did Ashley use for her necklace? Okay, I'm going to visualize what's going on. So Ashley's starting with 3/7 of a rope. Then she has this cut piece of rope, and she's actually cutting that into 7ths, and she's using 5/7 of that rope to make a necklace. What fraction of her rope did she use? So if I'm really stuck and I can't tell, is this asking me to multiply? Is this asking me to divide? I know it's not asking me to add because it doesn't say she has one rope that's 3/7 feet long and a second rope that's 5/7 feet long. How much rope does she have altogether? So I know it's not multiplication, and I know it's not subtraction. It's not asking how much longer is one rope, or she cut off 3/7 of a piece. How much is left? So if I'm really stuck and don't know if I'm multiplying or dividing, let's just draw out what is happening. So Ashley has 3/7 of a rope. So let's start by drawing her rope. This is her whole rope. And she cut 3/7 of it. So I need to split into 7ths. So there's a 7th of her ropes, and she cut 3/7 of it. So 1, 2, 3. Now she used 5/7 of the cut piece of rope to make her necklace. Okay, so she's not getting an additional 5/7. She's taking 5/7 of this piece right here. So of this piece right here, we need to find 5/7 of that piece. Now, you may have heard that word, a fraction of another fraction. She's taking 5/7 of 3/7. You may already know what operation to do, but let's make sure we know how to show that in a model. So 5/7 of this 3/7. Well, now I need to split this 3/7 into more 7s. And she's using 5/7 of this. So I'm just going to show them 1/7, 2/7, 3/7, 4/7. 5/7. Sorry, my shading got a little out of control. All right, and we want to know how much that is altogether. Well, I can count up all of these pieces that we shaded in. I'm also realizing now I know that this is a multiplication problem. I can tell because I was taking a fraction of another fraction. We were taking 5/7 of 3/7. So I can count up all of the pieces that I shaded in. I can figure out how many pieces there are all together, or I can use my standard algorithm for multiplication. Go ahead and pick which strategy you want to use and solve. It's a little bit faster for me to use a standard algorithm. My model is there in case I'm stuck and I don't understand what the problem is asking me to do. When I solve it out using my standard algorithm, we should have got to an answer of 15/49. She is using 15/49 of her rope to make for her art project. These words in here, what fraction of her rope? She used 5/7 of the cut piece of rope. These are just some really great clues that I'm multiplying. All right, let's take a look at problem number 2. Melissa has 5 pieces of string. She cuts each one into pieces that are 1/4 of the string. How many pieces of string does she have now? All right, you're trying this on your own. Go ahead and draw your model. Start with what Melissa has. Ashley has 3/4 of a rope. 3/7 of a rope. So we started by drawing 3/7. Think about what Melissa has. Go ahead and draw your model to match what Melissa has and what she is doing. And think about what Melissa is doing. And then answer the question of how many pieces of string does she have now? All right, let's check in. I drew out Melissa's 5 pieces of string. That's what she started with. She cut each one so that each piece was 1/4 of the string. And I want to know how many pieces she had. Well, if I count up all of the pieces of string that she has, Melissa has 20 pieces of string. All right, as a bonus, can anyone write this as a number sentence? Think about what she started with. Think about what she's doing to each one. This is showing 5 divided by 1/4 equals 20. All right, last one. Pedro has half of a can of paint. He needs to use it to paint 3 rooms in his house. What fraction of the paint can he use in each room? Go ahead and draw out what you know. Think about what Pedro is starting with. Melissa started with 5 pieces of string, so we drew 5 pieces of string. Ashley started with 3/7 of a rope, so we drew out 3/7 of a rope. Go ahead and draw out what Pedro has. And think about what he's doing with that half can of paint. And then you should be able to answer what fraction of the can of paint can he use in each room. And then bonus, if you can tell me this as a number sentence. All right, let's check in and see what you did. I started by drawing the half can of paint that Pedro started with. So this is showing the half can of paint that he started with. He didn't have a whole can of paint. He just had a half a can of paint. This paint must have already been used. Now he needs to use his half can of paint to paint 3 rooms. So just like with Corday's pizza, I need to split this evenly into 3 pieces so he can use this amount to paint the living room, this amount to paint the kitchen, and this amount to paint his bedroom. Now I want to know what fraction of the whole can of paint he can use in each room. Well, it's not just 1/3 because I have to consider the whole can of paint. This is where I like to draw my little dotted lines so I can figure out the whole can of paint would have had 6 pieces and he can use 1/6 of them for each room. As a division equation, that would be 1/2 the paint that he started with, divided by the 3 rooms he needs to use the paint for, and that would equal 1/6. All right, tomorrow, I promise we will get into some more standard algorithms, which I know help us just be a little bit more efficient. Today, our goal is really, do I understand what this problem is asking me? You are, on your independent practice, going to see some number sentences like this, where you just get to practice multiplying and dividing fractions. I still urge you, if you're dividing, to draw out your 4 wholes and cut them into thirds. Draw out your 1/5 and divide it into 4 pieces. If you're multiplying and you're feeling confident, feel free to go ahead and use your partial products with your array, or your strategy where you turn your improper fraction, you turn it into an improper fraction. When you get to the word problems, which you will have, make sure you're really visualizing what you're doing and just draw it out. If you get stuck, don't try to guess, is this multiplying? Is this dividing? Is this adding? Is it subtracting? Really draw it out to make sure you understand what it's asking. All right. If you need any help, please come to office hours at 3:15. Go ahead and bring the work you've done so far to office hours. You can show up with your models and say, this is what I did, but I'm not sure it's right. Can you check my work? That's what we are here for. Happy to see lots of you at office hours today. Other than that, happy solving. Best of luck. Can't wait